Welcome to the beginning of our Form 2 lesson. We are starting with circles and angles in the plane geometry 2. This is a circle. Now, where the marker was moving is called the circumference of the circle. Now, this section is termed as the circumference of the circle. Good. If there's a location, a point here as the center, if I draw a line from the center to any point on the circumference, that is called radius. From that same center, if I extend it to another end, this is another radius. Together forms what is called the diameter of the circle. Good. But if the diameter is not indicated, but there's a point in the circle, let's say from here to this end. Now, this section, as you are saying, is called a chord. Now, basically, a chord divides a circle into two parts, but the diameter divides the circle into two halves. And also remember that 2 radius is equivalent to 1 diameter. Let us look at the properties and then the laws that can be used to solve most of the circle angles question. Central angle. A central angle in a circle domain is given. Let's say we have a circle like this. Draw it a little bit bigger. And the center has been located to be here. So if I draw one radius here, and that same point, I move another radius. Now we set the angle to the point here. The angle created here, which is theta. The angle created here, theta, is equals to the external arc. So let's say here is O, and the point A and the point B is also located here. If we have that, then the angle created is the same as what theta, the arc. So in calculation, we say that angle AOB is equals to the measure of arc AB, which is equals to theta. Good. So whatever we have here is the same as whatever we have inner. When we are using protractor to measure, you realize that the angle we've gotten inner here will the same time be like the arc. Now, why is it necessary? This one is going to help us to be able to explain the fact that the angle a chord subtends on the circumference twice is subtended at the center of a circle. So let us go to the second session. Okay, so we look at the inscribed angle. This is an inscribed angle. Okay, so if I have got a chord here, and another chord also here. Good. Let's say here is A, this point B, and this point C. The angle created in a circle, which serve as a point where two chords meet, is what we call the inscribed angle. So we got the angle here. So I create the angle if here is theta. Then if here is theta and we are using protractor to measure, we realize that the angle created here twice is created at this point, that is the arc. AB is twice angle ABC. So this place is twice theta. And if we are measuring, we realize that angle A, or let me put it in a short format so that it will be as thin clear. Said angle BOC, angle BOC is equals to half the measure of the arc BC. This means that to measure of the arc BC will be equals to twice angle BAC. This place must be A, not O. So this is the point A, not O. Okay. Already we know that from the central angle perspective, this is what we realized. We realized that given a circle like this, and this section is the center, the angle created, assuming here is O, then theta equals to the external arc, that is the measure. So if I have here to be my A and this place to be my B. Good. So if that is the case, then judging from this, we can merge the first circle. This is the central angle and this is the inscribed. When we combine the two, we can get a figure like this. Just want to make it a little bit bigger. Then from a segment, I get my inscribed angle from that segment. Then from that same segment, I get my central angle. Good. Okay, so looking at it here, we can just give it a dimension. So this is my A, this point is my B, and this point is my C. So what we have is whatever, assuming here is theta or Q like this, then the angle which is going to be created here will be twice Q according to the dimension, because whatever the inscribed angle is equivalent to twice the arc AC. So this place will also be what? Twice Q. So if we've gotten twice Q here, this place will be twice Q. So whatever angle is created internally, now as the inscribed, that is the point, the angle equals subtends to circumference. You say twice is subtended at the center of the circle, meaning that if you measure the angle you are going to create, that's going to be created here, it is twice the arc. So whatever the arc is also equals to the central angle. So we combine the two, we get the first two laws, and we can use it to solve some questions. Let us try some WIAC related past questions on this. Now, before we start solving questions, let us try some of the various ways questions can be given. Now, let us look at this very figure very clearly. We can see that we have A, B, C, and D, but the external arc is what? AD. So we realize that assuming we take the line AC out, check it very well. If we take this section out, assuming I'm erasing it, you can clearly see that angle ABD has the arc BD. So whatever angle ABD is, twice is angle the measure of BD. So from this regard, we said that measure of arc AD is equals to twice angle ABD. Good. But if you are looking at angle ACD2, it is also having the arc AD. So we realize that measure of arc AD is also equals to angle is also equals to twice angle A, C, and D. So from this deduction, we can say angle ABD will be equals to ACD. So from this, we say therefore angle ABD is equals to angle AC and what D. So anytime you see such, just observe it critically and know that once they are inscribed angle and they are touching the circumference of the circle, then the angle created are going to be the same. Good. Okay, so we see various forms the inscribed and the central angle can be given. Okay, now we have here, this line is the diameter, it's passing through the center. So this is my origin. So you can clearly see I've got my inscribed angle. And this one is this one is central angle, and then the inscribed angle is ABC. So whatever ABC is twice is at the center here. Likewise, when I come here, though we have triangles with two different triangles. Now, this triangle is extended to the center, so it's the central angle. And the other triangle, that is ABC, is extended to the circumference. So whatever is created at the circumference, that is this line AB is a chord and BC is also a chord. So at the point where they are meeting is also equivalent to when it's multiplied by 2 is the one that will be at the center. Now let us come to a challenging one here where we got a circlist quadrilateral. Now we know the inscribed angled form twice is formed at the center. And we also have an inscribed angle form at below. So twice is formed at the top here. So if here is Q, we got twice Q here. And this place is Y, we got twice Y here. Now let us take a question. But before we take the question, we still have to note one thing. Now from the third diagram, this very diagram, this is the third diagram, we can conclude that angle PQR, angle PQR plus angle PSR equals to 180 degrees. This means that opposite angles of cyclist quadrilateral will sum up to 180 degrees. So we have angle created at Y and angle created at Q. They must touch the circumference. They will sum up to 180 degrees. Okay, so we are supposed to find the value of x in this diagram. There are several ways we can solve this diagram, but we can solve it simply. We know that twice angle PQR is the reflex angle at this end. So redrawing the diagram, we just solve it in this way. Let me create a space for my solution. Okay, so we said twice angle solution. Twice angle PQR is going to be the reflex angle here. We should just know that. Plus angle POR. If here is given as the center, here is O. There's O here as the center. Okay. Plus angle POR equals to 360 degrees. Look at it here. So I mean that whatever is here, this is the POR. The POR is going to be locating here. Good. So plus twice PQR. Twice PQR is the reflex angle at this point. So plus this is equal to 360. Then what do we have? We already know PQR, so we just indicate by going further. What the marker warrant me? Okay, so we can see it here. So we say plus angle POR equals to 360 degrees. Good. So we group like terms. So we get angle POR to be equals to 360 minus twice of 112 will give me 224. So minus 224. 224. Good. So angle we have gotten angle. When we subtract 224 from 360, we are going to get so from now we know this place angle POR to be 136. And the total internal angle of a rectangle sum up to 360 degrees. So from that, we just consider that rectangle have got, say from, you have to still say from the diagram. Let me use from the diagram. Good. We realize that we got x plus 112 plus 28 plus the angle POR, which is 136, must be equals to 360. So if that is the case, then what will be the value of x now? So x here will be equals to, so if we do the deduction, we can clearly say that making x the subject, we send 11228, then 116 to the left side of the equation, and it's going to be negative. So we sum everything before we let it cross. Now if I add 112 to 28, I'm going to get 140. 140 plus 136 will give me 276. Now there's a need for me to take 276 from 360. So I've got my x here to be equal to so making x the subject, we are going to get x to be equals to, when we subtract 276 from 360, we are going to get 84. So we write our 8 for degrees here to be the value of x. Marker is what I mean. Okay, so if you want the complete videos on the circle theorem, you just have to join our Facebook core math series. We got session for those in SS1, session for those in SS2, session for those in SS3. You can learn from all the year groups so that you can improve your maths alongside. So until we meet again, good evening.